Hello everyone. Uh, Hi Sahaj, what's up? Yeah, thanks a lot for joining. Thank you. Thanks a lot, Saurabh. Thank you. Hey Mohit. Guys, is my mic working? Is my mic working? Hello Bunny, thank you for joining. Thanks a lot. Uh, Hi Faisal, thank you for joining. Thanks a lot, guys. Is my mic working, guys? Can you just confirm? I hope it's working. Yes, it's working, Alam. Thank you. Thanks a lot. Yeah, thank you for joining. All right. Just let me know if everything is fine with the mic. Thank you, me. Thanks a lot. Thank you. Hey, Anubhav. Thank you. Thanks a lot for joining, guys. Um, all right. Whoever is here, please come and say hi in the chat. Thank you. Thanks a lot for me. Thank you. So, guys, what's up? How has it been? Almost a week now. Alam. Thank you. Yeah. Thanks a lot. Although I take bath every day, but then it's fine. All right. Um, who do we have? Yes, Saurabh. Thank you. It's been a long time, guys. It's been a long time, and I hope a lot of people will be joining tonight because we are doing it less frequently, so only on Saturdays and Sundays. So I just hope that uh, a lot of people will be joining tonight and they will not like to miss this thing. Thank you, thanks a lot, Lupidi. I've been waiting for this as well. It's just that I've been a lot busier with work. You must know, but I'm glad that a lot of people are joining now already. 12 watching. That's nice, guys. That's nice. If you have just joined, please make sure that you like the stream. If you don't like the content, then you can dislike later. But for now, just like that works. Thanks a lot, Mummy. Thank you. Um, all right, guys. All right. So we're gonna start very soon. Tonight is kind of a storytelling session. Initially, we're gonna talk about AI because I know a lot of people are very new to AI here. So I'm not gonna rush towards PyTorch and C++ because because that's something I don't want to do. Okay, so I'm gonna start with some of the basics that why do we need AI? Why should we really talk about AI for 2 hours, right? What does it deserve? And where are we actually going in the stream of computer science? If it is related to computer science or not, that's all I'm gonna discuss as well. So that is an important question. And all right, so that this is something in our bucket list for tonight, a small bucket, but then it's going to help us a lot. All right, Alam, thanks a lot. Yeah, thank you. I do get the point. I'm just having fun. Thank you. Thanks a lot. Ritik, what's up? Yeah, how are you? Nice signal. Thanks a lot. Thank you, Ritik. So I hope this is far better. Sounds interesting, Anubhav. Thank you. Thanks a lot, guys. All right, guys, do you happen to share this stream with your friends because this is just 2 times in a week, right? So let's expect a lot of people to join, and uh, this is going to help me as well and them as well. So please share with your friends. And you guys are still in the college, so I'm damn sure you must have batchmates, and so it's going to help all of us. Okay. So all right, I think we are good to we're good to go, right? Everyone, we are good to go. Are we good to go, guys? I'm gonna quickly. Okay, I'm gonna quickly do this thing. Just a minute, guys. Hmm. I have multiple monitors set up tonight for this stream, especially. It's gonna help a lot. Hmm. All right. All right. I think we are good to go, right? No, 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 Mohit, not flexing. I'm just saying that if I'm looking here, that means I'm just looking at the another monitor. Okay, I'm not ignoring you guys. The chat is here, so I'm gonna look at this monitor whenever I'm seeing the chat. I'm gonna look here whenever I'm coding. So this is gonna be my orientation most of the time. This is gonna be my orientation when I'm confused or I'm not confident about something. And this is gonna be my orientation when I'm just talking with you guys. Okay. So this sounds good. I'm just gonna be very honest at what's gonna happen tonight. I think we are good to go, right? All right. Let's start, guys. Let's start. Mohit, how are you, by the way? All right. Okay, Yatharth, sure, take your time, take your time. But we're gonna start now. I'm not. Let's start because time is 9:06. We can start now. And so, how many of you are new to AI, this deep learning thing? Let's just leave AI apart, okay? Let's just talk very specific terms. We're gonna use ML and deep learning. Whenever we are talking about deep learning, I'm gonna use deep learning because a lot of people use AI in generic terms. They don't really mean it's AI, but then they say that AI is an umbrella term. So I don't want to do that. I'm just gonna be very specific that when I'm talking about deep learning, I'm gonna say DL. Okay, when I'm gonna talk about machine learning, I'm gonna say ML. Okay, so this is going to help us a lot whenever we are trying to communicate. All right, so I'm going to talk about this tonight, that how it started. All right, and for all the people who are not from the computer science field, I just want to make this clear from tonight's stream that AI or deep learning or machine learning is not a computer science field. Okay, this is particularly like more related to neurobiology and psychology. So a lot of people who have worked in this field have done PhD in psychology or have worked before in biology, especially neurobiology, like dealing with the nervous system and all. So it's not computer science the way we see it nowadays, right? So even though I graduated in computer science degree, but I know that whatever I was taught is not at all useful for computer science, for this AI field, okay, especially in deep learning and machine learning. Okay, so first of all, just to make this clear, that if you're not from the computer science background, do not feel that you are not made for this or you can't do this. You still can get into AI, just like how we computer science people get into every field, right? We are in management, we are in everywhere, especially like engineering people, not computer science. So if engineering guys can get into any field they want, similarly, computer science people or non-computer science people start can get started with AI, okay, irrespective of what branch do they have. Because anyways, from the college we don't learn a lot, especially in the industrial, scene scenario. So that's important to understand that do not feel either confident or nervous about it, okay? But I'm going to share my screen now, guys. It's going to be really fun because, okay, let me quickly shift this to my, okay, all right. So I'm going to share my screen now. It's going to be really interesting tonight. All right. Just confirm, okay? You guys can see my screen, right? It's visible? Sorry. It's visible, right? The screen is visible. Okay. So I'm gonna start with something really interesting. Okay, I'm gonna show you that where we started. Like we really started in 1940s, no 1950s to be honest, late around 1947 or 1948, when a researcher started talking about this replicating the neurons. Okay, in our brain. So just like the whatever the basic part of our brain is, or nervous system is, that is neuron. So we started at that time when some researcher talked about it, we can replicate that to solve major problems like face recognition and all. So a lot of researchers started with this problem of face recognition and a few other problems, right? So we really started off with a huge confident build up all around that this deep learning is a big thing. At that time, this was not called deep learning for sure. Okay, it was termed with different names because a lot of people from psychology were coming up. They were trying to replicate what our human brain looks like. Okay, so as you see, like in biology, a lot of people, like a lot of researchers are still trying to replicate, to make an artificial heart, right? So like heart replacement surgeries and all, right now we are replacing with maybe real hearts or something, but in future they might just build a different an artificial heart and put it there. So it's not that easy that you just put it there, but I'm just talking in layman terms. Okay, so similarly a lot of people were discussing about, can we replicate the human brain? Okay, and trust me, that is AI. Okay, if just think about it, artificial intelligence, right? Artificial means we are talking about machines here. We're not talking about humans. Okay, human beings are not in the consideration here. When we are talking about artificial intelligence, artificial means we are just talking about something manual, something artificial made by humans, but not humans particularly. So, and intelligence means who are intelligent, guys? Come on, I'm intelligent, you are intelligent, right? So humans are intelligent, but not in real terms. But yes, we can term ourselves as intelligent, right? So artificial intelligence is something we are trying to make sure that we develop intelligent systems around, okay, which can understand from the experiences on new data set, on like incoming data which it has not seen before. All right, so that is a problem statement you think about, okay. And and to be really honest, what happens is AI is supposed to compete with humans in this, trying to depict or work on new data that is coming, which it has not seen before. So the machines are trying to compete with humans, but they're still not there yet. Because why? Because see, by the age of 22, I've seen more than billions of frames. Okay, because every time I'm seeing an image. Okay, right now, like I'm maybe seeing two laptops in front of me or something like that. Okay, so already there's so much data that is fed inside my brain that I know. So I have seen so much data set. So my human brain has actually learned a lot. So even if I see even if I see an animal which I'm not seen before, I can say that okay, this looks like something like reptile or something. Okay, because I've learned from my previous experiences. Okay, even though we don't learn from our mistakes, but we can definitely learn from the images. Okay, that's completely there. Okay. Hi Chirag, what's up here? Thanks a lot for joining, Chirag. So we're just getting started with what's AI. We're just getting started with how it all started, okay? So I'm gonna show you something really, really cool. So this guy called Frank Rosenblatt, okay? Guys, you can see the screen, right? So this guy is said to be the man behind Perceptrons. So Perceptron is just another name to the algorithm that we use for in deep learning or machine learning, especially for supervised learning algorithms. For those who know what is supervised, you know. For those who do not know, just chill, okay, just chill about it. Do not worry about like what is it and all. So this guy in 1956, no, in 1957, he made a perceptron for IBM 704 computer, okay, at Cornell Aeronautical Laboratory. Okay, for those of you who wonder, right, why is MIT famous, why is Stanford so popular, why is Cornell University so popular? It's not about just now. They started in 1940s about AI. Okay, they started working on 19 like in 1950s, and the IBM started working on in this field, right? Where people were not even talking about it, right? So it was really new. There was not enough funding around. So a lot of people just started at those times. Okay. And that's why these universities are so popular, right? Just like in India, a lot of old universities have worked on like maybe some different stuff. So they might be popular now, but not just because of the current situation, but also because what they have done before. Okay. So I'm going to show you something really interesting what he did in 1957. Okay. And I'm gonna show you the photo of it. All right. I know you can't see it completely. Let me just zoom in. Anyways, you can't count the number of wires here, but this was the first perceptron he made in 1957. Okay. It was called Mark 1 perceptron. Okay. And this is how it looks like. You can also see the name here, Mark 1 Perceptron is written. At least I can see, maybe you guys cannot see this. But then this was called Mark 1 Perceptron he made in 1957, guys. Do you understand? And this was doing something like AI thing at that time when there was not even enough computation available. All right? When we didn't have like NVIDIA GeForce RTX 2070 or something. So we didn't have a lot of graphics with us. We didn't have a lot of computation power with us. And at that time, he made this possible. Okay, but the results were satisfactory. Okay, for the initial start. The only problem was the computation was not enough to take all this thing because we wanted to train it further. Right? This is just one layer. Just imagine that this is the one layer. Then if we put layers on like layers by layers and layers, how complicated it will be. And we need a lot of computation for that, of course, because right, if you're trying to make it more complex, then you need more computation power. But at that time, we didn't have enough computation power, so that's why it kind of stopped. It kind of took a pause. Okay, and also because that time a lot of researchers felt that AI is this whole psychology thing, trying to build a neuron, trying to replicate a neuron human brain, from the human brain is a false imagination. All right, and it's not going to work out. So there were a lot of people who were in favor of AI, which is now called AI, right? Who were in favor of AI, who were in not in favor of AI, who were against it. Okay, so against the idea of it, right? So a lot of people didn't see the future by funding into these researches, and still till now, right? Of course, everything works by funding, right? People fund you for doing research, but at that time, people were not funding them enough. So it kind of took a break till 1990s, but then it suddenly took a start again in 1990s because this Moore's law came in, and a lot of like we had a lot of good inventions and progress in this hardware field. The competition power was increasing, and that's where it took off. Okay, it really took off in 1990s, that people again started talking about it. Okay, and there was one guy called Geoffrey Hinton. Okay, all right, guys. So let me tell you, guys, just like knowing about the people, like knowing about the Maharajas in India, right, is important for the history. Is similarly for AI, it's a lot. It's important to know about the people behind AI. It's important to know that who really started it, for you to know that for you to stay motivated. And even in this field, it's really nice if you guys know about this guy, Geoffrey Hinton. All right. So he is a legend. Okay, he is a legend, and he has won so many awards. And Turing Award is like he got with Jan LeCun and I think Yoshua Bengio, right? So these three guys are the major pillars in AI for now, according to the award, right? Turing Award is a big award, right? To get in 2018, he got this award, all right? So this guy in 1990s actually shifted to um, this University of Toronto, right? And there he got funding from like the Canada government and all that. So that's where he actually started working in AI because he felt that it's possible. Okay, he took this thing that a lot of people were talking about, that it's not possible, but he was brave enough to try this there, and he got funding from the government and maybe the university, and then he started working in AI field, and from then it's just a miracle what he has done. So he has received a lot of honors from the Canadian government as well. So this guy is a real legend, okay? And if you see, uh, as you can see here, Hinton received the 2018 Turing Award together with Yoshua Bengio and Jan LeCun for their work on deep learning. They are sometimes referred to as godfathers of AI and godfathers of deep learning. Okay, so they are like really big guys, okay? And it's like a dream for a lot of people to work under them. A lot of uh, people still admire them for their work. Okay, so anyways, I'm not going to talk in deep about this, like about his personal journey and all that, but I just want you all to know that he was brave enough to start this thing. And I've kind of heard a lot about him, that he cannot sit for a longer period of duration. Like, so he still has to stand and code. So he doesn't take metro and all. He walks to the university and all. So I was just curious enough to know about this guy Geoffrey Hinton. So he is also one of the guys who motivated me to start looking into this. So for sure. Um, okay. All right. So anyways. So this is interesting, right, Namrozbhai? Yes, he he shifted to Canada. I'm not sure. Yeah, he's from United Kingdom. He at least he was born there. But then, yeah. All right, guys. So this was about Geoffrey Hinton, right? But I really want to talk about uh, where it went wrong in between. Like a lot of people in 1950s worked on this, right? So maybe we have something like a good image talking about this, right? So Yatharth, we're just talking about the history of AI, right? And I'm just trying to explain what has been there for long, okay? And of course, I'm using just these images. I'm not really gonna draw them myself because full credits to the guys who made this. So, but have you guys ever heard about Turing test? Mohit, Yatharth, Namruzbhai, Ritik, Chirag, Sahaj. Have any of you heard about what is Turing test? So guys, Turing test, according to the guy Turing, right? What he said is, if you are in one room and you're trying to, like, what you do is you just say something back to the guy who is standing in another room, okay? And he responds back, and you are not able to differentiate whether that is the machine or the person saying. then you say that the whatever that machine is intelligent. So how do you term intelligence? Based on that. So if you're not able to differentiate between that is a person or a machine, then you can say that the machine is intelligent. So that was the criteria that if any algorithm of any machine passes this Turing test, then we are really good to go. So this is Turing test in 1950. He kind of made this thing, and it's still being used. It makes sense, right? If you're not able to differentiate between machine and the person, that means machine is intelligent enough, right? So a lot of people were talking about AI throughout this 1950 to 2000, right? But it actually took off in 1990s. As you can see, like from 1966 to 1997, we were really dead. Okay, like as in, because a lot of credits goes to two people, like I mean to kind of groups. One group was who was not in favor of who were not in favor of AI. A lot of people were talking against it in those times because they didn't see enough future in that. They said that it's just hypothetical thing that people are talking about. Another thing is the competition power we didn't have was we had was not enough. Okay, so and I'm damn sure, when NVIDIA got into the picture, IBM started working on this, Intel started working on this, AMD came in thoda, after a few years. So a lot of companies started working on competition power, and that's why a lot of credits goes to those guys for making sure that these algorithms can be trained on huge data sets using that computation power. All right. So from then it has just moved on. So this is just the achievements of AI, and you can see like 1997 to 2017 we have just moved on. Okay, so we have never stopped. All right. So this is what we have been doing all this while, and I'm gonna talk about it in every stream. I'm gonna talk about a few more things about AI, but for now it's a good motivation for you to get started, that whatever we are trying to use now is probably from 1950s as well. The algorithm, backpropagation algorithm, that we still use to train our networks, it was, I think, in 1970s. It was devised in 1970s. All right, so we are still using those algorithms. All right, so do not think that we have, in terms of algorithms, we have moved really far. But what has actually been better were two things. First is data set. Second is what? First is data set. Second is computation power. All right, because if you have enough data, you need computation power to train it on, because the power consumption will increase, right? So as you move on, the power consumption will be a lot. So you need more computation power. You need, like, the transistor sizes should get reduced. The amount of transistors should of course increase per year, according to the Moore's law, right? So it's gonna happen very soon, right? All right. So we have no you and all. Okay, Senpai, thanks a lot for joining. Thank you. And we have a comment from Serif. There are some Discord boards that use Turing test to come up with witty responses to whatever the user inputs in the chat. Okay. This. Okay. All right. Sahaj, know you. Okay. All right. Everyone is God over here, right? Okay. But this is the interesting part of AI. All right. So a lot of chatbots, a lot of things. You can say that a chatbot is perfect when you can say that we are not really able to distinct between whether the person talking is actually a machine or a person, right? Whether the it is a machine or the person, right? So if you're not able to say that, okay, who is this talking? Is this a machine in the chatbot, or is it really a guy? So that's where we say that, okay, our chatbot is working. All right. That's like, I mean, our chatbot is intelligent. That's what I mean, right? So that is a good criteria to set whenever you're talking about AI algorithms and applications. Okay. Right, Mohit, thanks a lot. Yeah, thank you. So we're gonna start now. We're gonna start talking about PyTorch now. But before that, I'm gonna show you what is possible with PyTorch, and why are we really talking about PyTorch and C++? Okay. So just quickly, I'm gonna talk about what is PyTorch. Okay. So how many of you really know about deep learning? Like, do you know what is deep learning and machine learning? What's the difference? Are you guys aware of the difference between deep learning and machine learning? Let me go to the chatting mode. I'm just going to talk about it for a few seconds. Mm, yes. Yes, okay, Navas bhai, you know, okay, Mohit, that's nice. So let me quickly talk about it, right? Okay, Senpai. Mm, yes, yes, Ritik, that's true. Uh, okay, let's start with this thing, okay? What is traditional programming? What is dynamic programming? So, you know, if you have some fixed amount of steps, like for example, let's say this. So we are trying to make a system for our coffee. Let's say Starbucks coffee. Okay, let's say Mohit got a job offer at Starbucks. Okay, and the manager says, okay, can you devise a software? Can you just develop a software which takes what is the order and prints a bill out of it. Okay. So if someone says, okay, just give me this kind of coffee, then he just clicks that option number and the bill is generated. Okay, and we then hand it over to the customer, and that is it. Okay. So the manager asks Mohit to do that. So what Mohit does is he creates a Java app or something or whatever, okay, whatever he knows. So he creates an app for that. He writes a few lines of code for that, and that is it. Okay. So that is a traditional algorithm, traditional programming thing because he knows that there's going to be a fixed number of steps in that. Okay, and he's just following those. That is it. Okay. So that is traditional programming where you know that there are fixed lines of code and whatever you're trying to devise or develop, that is not dependent on any prior experiences. Okay, you're not trying to make it work for some new data set or like some future instances, right? So and it's not going to be intelligent as well. So traditional algorithms like traditional programming ways that what we use it in first or second year of engineering as well, right? Mohit, okay. Right. So, okay, then let's say that you didn't flutter, okay? All right. But what happens is the manager asks Mohit next time, hey, do something like that, that the camera sees the person, okay, and it tries to, predict what kind of coffee he might like, right? Because it happens that people from 11, like maybe 18 plus people would not really drink coffee, right? Maybe they do, but it's more of a possibility that they might like strong coffee, maybe, right? And people teenagers or just children might just prefer something else, right? Right. So, Mohit, you like? Okay, that's nice. Hey, Chocolate Chip Charlie. That's a nice name, yeah. That's a really nice name, you know. Um, that's a really nice name. Name. Okay, okay. All right. So the manager asked Mohit to design a software or develop a software for that now. Now, guys, understand this. This is going to be an intelligent system. So it's going to be based on the previous experiences. So we're going to record. Okay, so Mohit came. His age is 22. He drinks this kind of coffee. Okay, Yatharth came. His age is double X, and he drinks this kind of coffee. Okay, so Ritik came. Navroz Bhai came. So we're going to record like Senpai came. Maybe he prefers something like expensive kind of coffee. Okay, so on a lighter mood. So that's going to happen, right? We're gonna learn from the previous experiences. Okay, and that is kind of a dynamic programming that okay, Navroz bhai, yeah, that was quite popular, I think, few months back, right, in the quarantine period. People were trying to make that. All right, so that is what's going to happen, right? So you're going to learn from the previous experiences to understand what's going to happen in future for those which we might have not seen before. So what might happen is maybe someone who is not looking like Mohit comes in and we have to predict what kind of coffee he might like. So this is what we really mean is should be intelligent, right? So that is not this is not traditional programming because we don't know the fixed number of lines of code like what we don't know the steps which are like we should implement and then also we are trying to learn from the data set, right? So it's kind of a learning algorithm that we are trying to use. Okay, but what's the difference between machine learning and deep learning? Right, so in a very nutshell, I'll tell you what deep learning is trying to replicate the human brain, is trying to use how our neurons work. It's trying, okay? We don't like I'm completely sure that we are not there yet, but it's trying to learn the way human brain works. So what we do is like when we are born, just imagine that you are born in India. How do you know Hindi? How do you know Telugu? How do you know Tamil? How do you know this language? There's so many languages because why? Your parents ask you, hey, kid, this is this thing, this is this thing, this is this thing. So you're given label for each object, okay, for each word. So that's how you learn a language, like when you're born, okay. So maybe you're born in America, then your accent can be like American, right? It can be anything, right? So that's really a learning algorithm that we always follow, and we don't really realize, right? So our parents used to tell us, right? Because that is cow, right? That is cow. So that's where we know that this is cow. Maybe they were all all wrong all the time. That okay, this animal is not cow. You know, this animal is not dog. This animal is not cat. So maybe they were wrong, but then this is how we learned, right? So that is deep learning. Machine learning is what? Machine learning is it's kind of trying to do the same, but the thing is what we are trying to use is statistical distribution. So whatever we are trying to do, how we learn from the data set, how we learn from the previous experiences, we try to understand how statistically it's distributed towards in the past and how it might distribute itself in the future. So it might just happen that it's trying to follow a linear path. Okay, that like for example, our CGPA is this from the first semester it goes down. For some people it goes up. For some people it stays constant, right? So what we can really do is if we have like first semester 7 CGPA, second semester 8 CGPA, SCPA, third is 9, fourth is 10. So now we know that maybe if he was there, he might have scored 11, but that's not there, right? That's not possible. So I'm just trying to give an example, right? So if I know that the student is not doing in the past, I for sure know that 90% of times he's not going to do well in future as well. So I'm trying to understand how the distribution is, the data is distributed, how in the past, all right, and that's going to happen. So that's what is machine learning in intuition wise. Yes. Okay. So anyways, so let's talk about PyTorch now. I really want you guys to understand what's PyTorch because we're going to use this library for deep learning whatever we do. So another library is TensorFlow, that's from Google, but I am a PyTorch contributor as well, so I'll be able to explain you better about PyTorch. So I'm gonna stick to that. So Senpai has a comment here, got a brief idea, but still not clear. What's exactly the difference? Can you give an example each on the application of both DL and ML? Senpai for sure. Um, all right. So you want an example, right? Maybe you can take. We're gonna talk about it to be honest. I'm gonna show you that. So it's really we're gonna work on those applications. I'm gonna tell you about what is the exact difference. But if you really want an example right now, you can just think about the faces. So I'm sure you were not there during the face detection stream, but earlier what we're trying to do was detect a face out of the image. Okay, so if you're given an image, we want the face. That is the problem statement. Okay, so what we need to do is the machine learning way is what you have a whole data set for both machine learning and deep learning. We have a data set. Okay, so the data set is not going to change. All right, the format is going to stay the same for now. We have an image, we have the what do we have? We have the bounding box, that is the coordinates of the face from the image. Okay, so what machine learning is going to do is going to try and fetch the features from the image and try to understand what's the kind of distribution of those. Maybe one feature is the brightness of the eyes. Okay, like in this area one feature is what's the brightness, just to decide whether the face is there or not. Okay, I'm just giving an example. Okay, and it's going to plot for all the faces. It's going to understand that what kind of distribution it is, what kind of pattern it follows. So it's more like a pattern matching thing, that okay, for these kind of faces or for all the faces the brightness should be really dark here. So it understands from the all the images that okay, this should be dark. But how does it understand? It understands through the statistical models and all. Okay, so the algorithm is not really related to the human brain, how the human brain uses. Okay, but for deep learning, how it does it, it has a lot of neurons over there and it fires one neuron. So it's a really a biological thing. I'm going to explain it later on. That's why I didn't I didn't go in details. But what it's going to do is it's just going to pass the data set to the algorithm and it's going to do something like logistic regression and all those things. Okay, it's going to give you the label. That is it. And it's going to learn from the experiences. But it's not using statistical models. It's trying to uh, learn the way human brain learns. But Senpai, this is only possible when I start, showing the examples. So that will be more clear later on. Mohit, yes, yeah, Jeevan Jali, yes. Let's not talk in Marathi. No, Mumbai. Pratik, I guess, so Pratik bhai, we thought we should shift back to 9 p.m. for some people because some just want to sleep early, including me. Simpai, you have a comment. So is it that when you use a neural network, it's called DL and otherwise simple algos like gradient descent is ML? Like see, gradient descent is a different algorithm. Okay, it's used to find so gradient descent is something else, okay? But algos like logistic regression, linear regression, no, not logistic, linear regression and all those things are ML, okay? And yes, neural network, whatever that contains neurons is completely DL. Yes, deep learning. Uh, by the way, deep learning means deep neurons, okay? Deep neural network kind of thing. So it has to be a lot of layers in it. That's why it's called deep learning, right? Because we are going deeper into this. Yes, yeah. um, Gradient descent is for like understanding parameters and optimizing them. All right. So yeah, Anubhav, your question is TensorFlow versus PyTorch. PyTorch wins with a huge margin as far as deployment is concerned because also research. A lot of people are talking about PyTorch nowadays. Production wise, I love PyTorch and yeah, so PyTorch is really nice. TensorFlow is also growing, but then I'm not. I love PyTorch, so I'm going to be biased towards PyTorch, but both have their pros and cons. We have Mohit, CNN, RCN. Yes, yes. So those are for images, Mohit, and for sure those are like deep neural networks. Senpai is saying, Acha, okay, can you please plan a session for explaining the proof of that? Yes, for sure, Senpai. So that's one of the things we used to learn, like used to learn a lot of times during engineering in computer science. Whenever we had this AI or deep learning subjects, we were taught about this proof of backpropagation. Okay, so we're gonna talk about it for sure, Senpai. So that will be there. Thank you. All right. So I'm gonna start now. Okay, I'm gonna start talking about PyTorch because it's gonna be really interesting to talk about something I've done before. Okay. All right. So, how should we start? What's the best way to start? So I'm going to talk about PyTorch now. PyTorch is just like OpenCV, okay? It's just like an open source library. OpenCV was for computer vision, and then PyTorch is for deep learning, okay? You just understand that whatever applications we have in deep learning, one of the possible ways is PyTorch because it's just kind of a tool that like it has a lot of code written inside it, okay, but we can just be write simple lines of code to train our deep neural networks and play with eigenvectors and all, okay. So anyway, so this is PyTorch, okay, and it was primarily developed by Facebook Research Fair. So a lot of people call it Fairy, just to make fun of them, but then these guys are fair, okay. So Facebook's AI research lab, all right. So uh, just understand that these guys are heavily funded by a lot of people and a lot of industries, and the fair is really nice, and they are constantly working on developing PyTorch and trying to make it better for industrial use as well as researchers. So that is what PyTorch is, and it's also open sourced. So whatever the source code is, it's open sourced here in on GitHub. So that's one thing which is really nice, okay, about PyTorch. And all right, so this guy is a he's really nice. So this guy works at NVIDIA in the DL frameworks team. I worked with him and he has so many contributions in PyTorch. He's a legend. All right. I should not get distracted. Okay. So as you can see about PyTorch over here in the repo, it says tensors and dynamic neural networks in Python with strong GPU acceleration. Okay. So that is what is important about PyTorch. That whatever deep learning library we have to make sure that it works well on GPU. Okay. So we do like they really focus on GPU acceleration, and that's why they have a collaboration with people from Intel, they have a collaboration with people from AMD, they have a collaboration with people from NVIDIA. So whenever NVIDIA releases a new GPU, they make sure that PyTorch is working fine on that GPU. Okay, so like for example, maybe some GPU comes in and they don't just release it, okay, they test PyTorch on it before releasing the GPU, because that is the task of NVIDIA to make sure that, because it is a use case, right? Whoever is going to buy that GPU, if PyTorch is not running fine, a lot of researchers will not prefer NVIDIA. Similarly for AMD, like and similarly for Intel, right? So GPU is for sure, yes, Senpai. So GPU is not all about gaming, right? And I'm going to show you how GPU has this GPU acceleration has moved past a lot of things, has made a lot of impossible things possible right now. Okay, Ritik, yes, for sure. I'm going to talk about installation. Mohit, TensorFlow क्यों नहीं? Why not TensorFlow? Because I love PyTorch. Yes, Yatharth dil se PyTorch. And you know, PyTorch is going to help you a lot in your future as well. If you know any one of the libraries, you can definitely shift to the other in future if it's required. I think we're going to definitely talk about installation. And Sinpai, yes, I'm going to talk about this. So guys, I know a lot of you are here gamers, right? So you do really see, okay, in the specs what kind of GPU the gamer has, right? Maybe 8 GB, maybe 12 GB, maybe 4 GB, only 2 GB, right? Some people don't have GPUs and the game doesn't work. So GPU is not that is definitely not about GPU is definitely not about gaming, and GPU is definitely not about graphics. Okay, so GPU is about acceleration anywhere you go. Okay, and GPU is mainly about matrix calculations. So wherever you see images, wherever you see arrays and arrays, like right, matrix is what 2D array, 3D arrays, right? So whenever you see matrices, whenever you see a lot of numerical computations related to arrays and matrices, we're gonna use GPUs for that. Okay, so we're gonna do that, and that's where graphic processing units, NVIDIA has come in, right? So without NVIDIA, without Intel, without AMD, this would not have been possible, right? So, and of course IBM as well. So these guys are legends in their field, right? um, मोहित PyTorch कितना दिया? PyTorch कुछ नहीं दिया रे. PyTorch didn't give me anything. They just gave me an opportunity to contribute. All right, Yatharth, yes, we need 1 TB GPU. That doesn't exist, I think. Um, so of course they have limits, right? You can't have just like RAM. So RAM is really cheap, and this GPU is really expensive for sure. Very obvious, right? So all right, so we're gonna talk about this now. How to install PyTorch? Okay. So as I told you guys, do you remember how to contribute to open source? So there are kind of steps that you should follow. What are the steps? Do you guys remember the steps, guys, for contributing to open source? Okay. So I'm going to talk about the steps right now. Okay. I worked on DGX and DGX2 servers. It was really fun at NVIDIA, but you know what? You don't always need GPU. Okay. We don't always need good GPU. Like good GPU in this sense, like, it's not that you need 8 GB GPU all the time. Okay, some things are not just GPU extensive tasks. For some things, Intel like RAM will work. That is it. Okay, so don't just blindly go and buy a GPU. Okay, don't just be like give me 12 GB GPU of GeForce RTX 2070, and if you're not just doing any matrix multiplications and all, right? So okay, so I'm gonna go to this website called pytorch.org. I'm gonna share the link with you. Of course, it's a small link, right? And Pratik, thank you for coming in the chats and trying to help people out. That helps a lot. Okay. Uh, so all right. So what you need to do is you need to go to install PyTorch section of it. Mohit, I'm gonna go very slow. Just I suggest you guys to not follow along. Just try to understand what I'm doing here. Then you can do it later. Okay. But if you want to follow along, you can do it. So it's kind of a slow and steady session only, all right? And so what we're going to do first is we're going to install the PyTorch, okay? And this is really important that you meet the prerequisites. So make sure that you have installed NumPy as well. So NumPy is a library that you use for numerical computations and all, okay? All right, so what I'm going to do is I'm going to pick the stable version. I hope you guys know this term, right? Preview is something that is kind of a beta release for them. And stable is something that they have tested on all the systems and they're ready to go. Okay, so all the use cases have been solved for stable. Just just giving an example, okay? And that's the 1.7 version. So PyTorch is really, really fast. I think they have one release every month. Okay, so 1.7 is their current release, stable release. Okay, I'm gonna click there, and Linux is what? Linux. I'm gonna click on Linux because I'm gonna install it on WSL. For those of you who don't know, I'm using Windows, but there's a thing called WSL, Windows Subsystem for Linux. It's just like a VMware, but kind of different. But you can term it like that in layman terms. All right. But the important thing is I'm gonna use it in C++. Okay. So to install that, the PyTorch C++ API is termed as LibTorch. Okay. So LibTorch I'm gonna use, and as you can see, um, all right. Just a minute, Sinta. I'm gonna come to this point. Really nice question. So of course I'm gonna come just finishing this up. Okay. I'm really sorry. Okay. So I'm gonna go to stable version. I'm gonna click on Linux. Okay. I suggest everyone goes for Linux. Mohit, you especially. And then you will come and say there's an error. All right. Anyways, you can choose anything. Okay, that works. Go to LibTorch because PyTorch C++ API is called LibTorch. Okay, it's a really nice name for that. And I'm also going to explain why. And then you have to choose, like, of course, we are doing it in C++. So you have to click on C++/Java. So that will give you the binaries and all for C++. And what you have to do is you have to select the CUDA version you have. For now, I suggest everyone go to none because you will not have CUDA installed on WSL for now. Okay, I'm damn sure. So just click on none because we're not using a GPU for that. Okay, we are not going to use GPU right now. We're just going to stick to the CPU version of PyTorch because it's going to be a lighter weight and it will not have a lot of errors initially. I can't debug in chat, that's why. But I will surely switch to the CUDA version after we install CUDA on WSL. Okay, I've already installed, so I'm gonna stick with 10.2 version of CUDA, and I'm gonna download this thing. So I'll just click on this. So it says CSS11 ABI. So ABI is just something like you have a lot of libraries installed in different way. So if you have used pre-CSS11, like that ABI previously, so you have to go for this. But for now, you can just experiment. Whatever works, you use it. Okay. So if this is not supposed to work, this will give you an error, and then you can quickly shift to this. Okay. That should solve all the problems for now. Okay, let's talk about it now for now, okay? Senpai is saying, sorry to interrupt. Can MATLAB be used too? I guess it's not efficient enough as compared to these other options because I've never heard of anyone using MATLAB for MLRDL. So Senpai, let me tell you this, like we used to use MATLAB for digital signal processing, for speech processing, for image processing. So MATLAB has a lot of existing tools to make our work easier. So MATLAB is definitely used for machine learning and deep learning, but not in deployment because it's slow. Okay. Also, it takes a lot of space when you have to install it, right? So suppose you have to deploy a model to the traffic light over there, and you don't have, of course, you will not have enough space in devices which we are using for performance efficiency. All right. So MATLAB also is not open sourced. So a lot of things which are happening behind the scenes, we can't really take a look at them. So sometimes if you want to use a customized algorithm, it will be really tough for you to devise and develop it. So MATLAB can be definitely used and still used by researchers because it's easy. You don't really need to learn programming to use MATLAB, although it has its own language. MATLAB is a language as well. But then, yeah, I hope that answers your question. Mohit, I hope I answered why, because let's just stick with none for now. There's a way to install CUDA on WSL, but I think it's going to take you guys some time. So, all right. I'm gonna thank you. Okay, great, Senpai. Thanks a lot. But before this, okay, should I talk about installation first? Okay, let's talk about the installation first. Okay, so once you've clicked over here, you will get a zip file over here. Okay, you have downloaded the zip file. Okay, let me show you the zip file. Okay, so if you go to this folder, there's a LibTorch folder in it. Okay, there's a LibTorch folder in this, and there are a lot of libraries. Okay, so these are all the libraries. So these .so files means these are libraries. That means someone has compiled the code and saved all of it in the form of .so files so that you can just directly import. Okay, you don't have to build it from source and all. Okay, and include are just the header files that we have. For those who don't understand the organization of a C++ library, don't think much about it. For now, I'm just showing the content of LibTorch downloaded code. So Yatharth CUDA is a parallel programming platform, computing platform by NVIDIA, only for NVIDIA GPUs. So no, it's not related to that. That is different. Ashish, good evening. Yeah, how are you? Thank you for joining. All right. So I'm gonna go ahead and start talking about PyTorch, okay? And I'm gonna start explaining how to use it, okay? So let me quickly go and so I have a folder called, okay, let me zoom in. Let me zoom in for you guys. So I have a folder called projects, documents, projects, and installations. So right now I'm in the WSL, okay, and I'm using Ubuntu here, okay. So I'm in documents, projects, and installations, and if I hit enter, I've downloaded this CXS11 AVI thing, okay, and we have this zip file over here in this folder, okay. If you want to copy it from, so you can directly do this, okay. C. So this is what you have to do: /mnt/c/users kushasho, that's your username, downloads. So this is how you come to okay, it will come down to downloads, and then you can go to this libtorch zip file and just hit space and dot. So this dot means that I'm trying to copy this file to this current repository, okay, that's it, and hit enter. All right. Thank you, Pratik. Bye. Eat well. Take care of yourself. And yeah, I'll be on till 11, I think. And yes, I'm definitely going to stream tomorrow as well. So Saturdays and Sundays is going to be there. Thank you for joining. Thanks a lot. All right, guys. So what we're going to do is we're going to copy the zip file to this current repository. So I've already copied, so I don't really need to do that now. Okay. And if you see, we have here LibTorch. So what I've done is unzip the repository. So how do you do that in Linux? You just use a unzip command and use type the path of it, right? So you can just type the path of it, like maybe if it's pre-cxs1 abi.zip, so then you just type unzip space the file name, and it's gonna unzip for you. Okay, it's gonna extract the contents in the current folder. All right. So I've done it already. So I'm gonna just go to libtorch folder. I'm going to do ls. So as you can see, like as I was explaining before, we have all these folders: bin, lib, include, share, all these things. Okay, so we have these things already here. So now how do you use it? I'm going to explain now. So there's no installation process, guys. Okay, there's nothing you have to do. You have downloaded this, that is it. Directly you have to use it then. You have to do nothing from here. Okay, so Ritik, if you're here, Mohit and everyone over here, like Yathat, Ashish. Ashish, I'm good. Yeah, thank you for asking. Thanks a lot. Senpai, thanks a lot. Everyone who has joined and who is here, please say hi in the chat so that I know you guys are here. It's easy for me to communicate. Okay. Right. All right. So this libtorch folder is the final step of installation. So you don't have to do anything from here. Okay. Just make sure that you install NumPy as well. How do you install NumPy on WSL? First, you install PIP, which is the Python package installer. So Python 3-pip. Okay, that's the first command you have to do. And the second next command is what? pip3 install NumPy. So you can directly use these commands to install NumPy, and that will be it. I'm gonna copy this and paste in the chat for you guys. So by the way, these double and also called ampersand is just that it means that I'm saying that okay, first do this command and then do this command. Okay, if this is successful. Okay, so for that I use double ampersand. Alright guys, so this is about installation of PyTorch C++ API. Okay, and now I'm gonna talk about why C++, guys. Come on, do you have this question that why not Python, why C++? Do you have this question that why are we doing deep learning in C++ and why not in Python? Because everybody does it in Python, right? We see so many tutorials in Python, we see so many people doing it in Python, so why not Python? uh, I think I should turn off the night light as well. Just a minute. Turn off now. Ah, better. Blocking this blue light is not good at all. Senpai, so I'll tell you what. So PyTorch py means Python for sure, and we are doing PyTorch in C++. That's called LibTorch. So it will not be in Python, but parallelly we'll be doing everything in Python. But our basic aim is to do it in C++. So we are gonna do we're going to do deep learning and everything in C++ now. And for some reasons, But if you're curious, I'm going to explain it now. Guys, are you curious why C++ and why not Python? Right? I think everyone is curious about it for sure. If I were you, I would be, right? Yeah. Senpai, so okay, I'll tell you, right? Okay. So what happens is there are few reasons, okay? First of all, think about this. So C++ is I think 10 times faster than Python, okay? All right. And the Python interpreter, whatever there is, it takes a lot of time. So when you're talking about efficiency, performance, okay, C++ is really fast. So if we are able to do deep learning in C++, it will be really faster than what we do it in Python. That's the first thing. So if you have any application where you need really high FPS, frames per second, okay, you really need high performance, you have to make sure that either you're using, Python, which is a kind of C and Python combined, or you're using C++ for some part of it, okay, for not like training, you can do it in Python, you can have a model ready, and then you can deploy it in using C++, okay, that's what I'm trying to say. So you can train your model, you can train the algorithm on the dataset using Python. You have done the training, you got the model, you then pass the model to C++ for deployment to the whatever application we have. Okay, so for real-time purposes, it is really nice if you can use C++. Uh, Using TorchScript, right? Yes, yes, that's right. Dakshita, yes. By the way, welcome to the stream. Thank you for joining. I think you talked about having a PyTorch C++ series, right? So there we go. Okay. So yes, we're gonna use that. So what we're gonna do is essentially we're gonna follow this method always, that we're going to train the model in Python and we're gonna use it in C++. So that's something that we can do. So the other use case is what? Sometimes what happens is all of the existing framework, whatever the developers have done. Let's say you just joined a company and it's 50 years old company, okay? And C++ is the old language, right? Not that old, but then yeah. So whatever they have developed so far is written in C++, okay? And then you come in and say that, okay, I don't know C++, I only know Python. All right, or you say that okay, PyTorch is already in Python, so we can't use C++. What will happen? You have to change everything from C++ to Python. Okay, the framework has to be changed, right? So to avoid that, what Facebook developers did is they released this library which is closer to what we have in Python, like syntax wise, whatever you're trying to use, like you torch.tensor, we have torch scope resolution operator tensor, just like OpenCV, right? cv2.imread, cvimread. So it's just same in PyTorch as well. So you have an option to use C++ as well if you're good in C++. If all the software exists in C++, then why use Python? Alright, we have a comment from Senpai, but at the end, the final binary that will be built after compiling, why will be there a difference in running that between Python and C++? The only reason that I can see is the inefficiency of the Python interpreter. Senpai, there are a lot of other reasons as well, I'll tell you. Another reason is a lot of libraries like TensorRT for optimization, uh, you know, they are closer to what we have in the source code, okay? Because PyTorch is written in C++. Okay, all of the source code is written in C++. All right. So the when you call a function from Python, we have kind of bindings enabled. So the source code is in C++. You're calling from Python, so it goes through a way which takes some time. But if you're the source code is in C++, you're calling from C++, the dispatch is you call that dispatch. The dispatch time taken for that is really less. Okay, so it's gonna take a lesser time. So that's gonna happen for sure. Okay, and yes, at the end we're gonna have binary. That's for sure. But apart from the interpreter, that's also the reason for. And another reason is we have so many libraries for performance boosting. Like from NVIDIA, we have TensorRT, DeepStream SDK, and all those libraries which are written in C++. Okay. So it is easier to write the code in C++ for us to combine our code with them with those libraries, right? Sinpai is saying, but once compiled, should it not make a difference? It doesn't. No, it will not make a lot of difference for sure. But that's what I'm trying to say, that apart from the interpreter, it's also about existing framework. So if all of the code is written in C++, then why switch to Python? That's also one thing. Okay. Another point is you cannot use multi-threading. Like you cannot use all the threads efficiently in Python because it allows only one thread per time. Although you can use multiprocessing library, but that's still not efficient. In C++, we have all that support. You can use pool threads. You can do multiprocessing. So if you want to use all the cores at a time, you want to play with your computing power, C++ is highly efficient. Anubhav, why not use C? Because C is first of all not object-oriented programming language. So the way our code is organized is really better if we have object-oriented techniques. Also, another thing that the source code is written in C++ and it's not backward compatible, right? You can't use everything written in C to C++ as well as C++ to C, not all. Okay, so that's also the reason because PyTorch is written in C++. So we're gonna stick to C++ for now. Um, Rudra, I'm good. Yeah, thank you for joining. Thanks a lot. Uh, Oh, all right, Senpai, there's no issues. Is there anything in Golang that's used for ML? Uh, I'm not really sure. Go is definitely used for ML. I've heard about it, but then Julia is the new language that's being used for machine learning. So if you're really curious about learning a new language other than Python and C++, Julia is the way to go. Yes, Dakshta, that's really true. Let me know if I'm pronouncing your name properly. If I'm wrong, just let me know. Okay, I'm really sorry. Okay. So that was about C++ versus Python. Okay, and for me to explore C++, the idea was to try and understand the source code. Okay, so what happened was I wanted to contribute to PyTorch as well. So since okay, let me show you. If you guys that will be easier for you. So um so I'm gonna show you one example, okay, of one function. Okay, that will be easier. Let's go to this code. Okay. And I'm sure you guys know about cosine sine functions, right? You know about that, right? So, okay. Like you guys can see from here, okay? So we have a sine function here and everything is implemented in C++, okay? So all of the code that is written, and this is just one line of code, but for this implementation, we have so many lines of codes, okay? So we have everything written in C++. So that's definitely going to help us if we are comfortable with PyTorch and C++. If you want to really be a contributor and work in Facebook for these guys. Um, Atal, that's great to know, yeah. I hope you enjoy the vacations as well, and thank you for coming. Thanks a lot. Dakshita, how do you contribute though? Like to contribute, one should know full framework. No, you don't need to know full framework, but you should definitely be comfortable in C++ for some parts of it. Like you can definitely contribute by writing test cases, which are written in Python, but knowing C++ and trying to understand these parts of PyTorch is important. Okay. All right. Hello Sachin bhai, thanks a lot for joining. Yeah, thank you. It means a lot. Thank you. All right, how are you? So guys, this is the reason why we are doing it in C++. All right, and let's try to look at one of the codes that I wrote for PyTorch. Okay, and I'm gonna show it to you so that you guys know what we are gonna do eventually. Okay. Sorry guys, I'm just should be a little. So I contributed this code to did I contribute this one? No, or did I contribute this one? What happened? No, I didn't. Which thing I contributed? Yeah, I forgot. Just a minute, guys. I think I'm definitely sure I did. Uh, right. So you guys can see KRS Shimali added transfer learning using LibTorch and OpenCV, right? So I contributed this in the examples repo. Okay. Sure, Mohit. It will, yeah, it will. All right. So I contributed this thing to PyTorch. I think 1 year back. Wow, that's nice. All right, so I'm eventually we're gonna go through this, okay? What I have done before, and I'm gonna show you how to do this step by step. So that's our target, okay? So our target is to make sure that we are able to write this code ourselves from scratch, okay, and understand each and every line of code. All right, so this is going to help us a lot. And if I have, so one of the coolest things about what I did was also about using Jupyter Notebook. For those of you who know Jupyter Notebook, it's really nice to use because it gives you kind of a, cell by cell view that, okay, you run this code, you shift plus enter, then you are done. So for C++, if this was available, it would be really cool. So I I kind of did this for C++. So every cell will have a code. You don't have to compile it always. You can just run this cell and your output will be done. Okay, so that this is something I did for C++, using the existing libraries and all. Full credits to them for that. But so this is something we're gonna use, and of course credits to my brother as well. So Vishwesh Ravi Shimali had helped me a lot in this, so I'm gonna use his help as well for this. Okay, so this is something we're gonna do. Okay, Dakshita, do not worry. Okay, yeah, Kling. So they changed a few things for Linux. I think they don't have a support for Linux or Windows, either of it. Okay, so I'm gonna check that for now, and I'm damn sure that they have this in the to dos. But we'll try to figure this out. Okay, Dakshita, we'll try to figure this out together. All right, guys. Okay, okay. All right. So this is something we're gonna do. Okay, but now I'm gonna tell you how to get started with PyTorch and C++, how to use this library. Okay. So let's do this. So what we have done is, so far we have a LibTorch folder here existing. Okay, and I'm gonna go to my samples repo. Uh, okay, so I've created a samples repository for me, that where I'm gonna test this LibTorch repository. Sorry, LibTorch library. So I've written a sample.cpp code where, let's just remove this. Okay, let's just remove this. Okay. All right. So the first step is always to try and include the library that we have for Torch. So we have the library torch/torch.h. That is the header file that we have to import. In just like in Python, it will be what? Import torch. In C++, we have hash include torch/torch.h. Okay. And IOStream is for what? Is the input output stream library. Oh, sorry, my bad. Okay. So this is the input output stream library that we're just going to use for C out and all. Okay, so what we're going to do is, let's just have a main function here, and we are trying to create an identity matrix. How many of you know what is an identity matrix, guys? Do you know what is identity matrix? Identity matrix. Do you guys know about identity matrix? Yes, Ashish, do you know? That's nice. Just a minute. uh Diagonal ones. No, senpai, bhai, that's not. um is that identity matrix? No, that's not identity. It is all ones, right? No, maybe I'm wrong then. Identity matrix. It's all, oh, it's diagonal one, right? Okay. Then, all right. So I matrix is different, right? No, I is the same. Okay, sorry. Okay, we are right. All right. Okay. Sorry, guys, I got confused. So that's true. So Senpai is right and Yathat is right. Oh, Vishwesh, he's here. Thanks. All right. So we have everyone here, right? And this is what we have as identity matrix. Yes, Vishwesh, yes. AI is equal to I is equal to A. Yes, that's right. Sorry, I got confused. I'm really sorry. Okay, but that's fine. All right. So how I'm gonna write a simple code for here, and you're gonna definitely understand what's happening. So tensor, just consider this is an array, but which is differentiable. Okay. So this is differentiable. All right, and we have torch tensor as tensor and torch I 2, 2. All right. So we have a dimension is 2, 2. So we're gonna make an identity matrix of dimension 2, 2. Thanks Navroz bhai, thanks a lot. Tushar, you don't need to spam, brother. It's okay, na. If you're here for learning, you can of course learn, but then don't spam. We are doing GitHub rates, but we're not doing YouTube rates for now. That's not going to happen, okay? Because we are not popular. Simple reason. All right. So all we are trying to do is we are trying to create a tensor here of size 2 comma 2. So the identity matrix should look like this, right? 1 0 and 0 1, right? So two rows, two columns, and we have we have 1 and 1 here. That is it. So and then finally we are trying to print this. Okay, that's it. I'm not gonna use endl anywhere. Okay, I'm gonna use new line character because it is fast. I'll explain this in the later section of the streams, but I'm gonna stick to the proper convention streams. Okay, sorry, convention practices. So that's all I'm trying to do here. So nothing to understand. We are trying to create an identity matrix and we are trying to use PyTorch C++ API to create that tensor. So let's try to do this. Okay. So we are using the CMake way, right? Do you guys remember that we use CMake for OpenCV as well? So CMake makes it easier for us to find the PyTorch library. Okay. So I have written that PyTorch, the CMake list.txt file here for all of you. So this first line is you should always include. So for you guys and everyone who is here right now in 2020, CMake minimum required version 3.0. Fatal error, this is gonna stay the same for you guys. So what it's trying to do is, because for different CMake versions you might have different commands. So for 3.0 we have these commands. Maybe in 4.0 4.0.x versions it will be different. So all we are trying to say is the minimum version of CMake should be 3.0. Okay, and if it is not, then it returns a fatal error. That is it, it stops. So the next thing is we are trying to name the project. I have named it Kiyashimali-torch. And then what we are trying to do is we are trying to find package name torch, and we are saying that it is required. That means if you do not find torch, stop. Don't go further. Don't say that is successful. Okay. So that's what we are trying to do here. Then add executable file. That means we are trying to add the source file to our project. So we are saying okay that this project is linked to sample.cpp file. Okay. So whenever we are compiling this project, okay, this sample.cpp will be compiled. Okay. All right. Then target link libraries. What we are trying to do, we are linking the libraries of Torch. See, every library has it. Like PyTorch is a whole set of libraries. Okay, it has so many compiled libraries. So we're gonna link them to the project. That is it. And this is a variable. Whenever we use dollar in CMake list.txt, it is a variable. Okay, so this Torch libraries is a variable after we have found that Torch. And then finally we are saying that okay, this project, make sure that we are using C++14. So the version of C++ we are using is 14. Okay, just stick to these and you'll be good to go. So as a good programming practice, you should always create a build directory. Okay, so how do you create build directory? mkdir-p build and cd build. So it's going to create a build directory. If it's already there, it's going to just leave it there, and cd build is going to take us to the build directory. So now we are in the build directory, right? All we have to do is CMake. So this is the tricky part, guys. Okay, you have to pass the prefix CMake prefix path. So this is a CMake variable which takes the path of LibTorch library, and you have to make sure that it is absolute. Okay, so I really say I really prefer that you guys pass the absolute path and not relative path. Relative path will be like dot dot slash dot dot slash installations. You should always make sure that you have the absolute path over here. That will really help. So it's gonna find, it's gonna search for torch library in this folder. That's what we are trying to say. Okay, and if I hit enter, see, it detected CUDA for me. Okay, that's nice. It found cuDNN, which is also a requirement for CUDA, just for different stuff, and it has written the build files here. Okay, and all we have to do is after CMake, what we have to do, make and hit enter. So it's now gonna compile the code for me. That is it. Once the compilation is done, I can run the code. Sorry guys, there's some error. And okay, There's a small error, guys. I just made a small mistake. Nothing big. Okay. uh, Dakshta, that is so hyphen p is for what? Like if it is already existing, do not give an error. Just let it be. So sometimes you're trying to create a repository which is already there. So it will just leave it there. It will not tinker with it. Guys, I'm just gonna try and run this code first, okay, and see if this works. If it returns some error, then I'm gonna take a look at it. What's the problem? Okay, so it is expecting an I. Okay, wow, that's weird. I didn't know of this, to be honest. Let me just try and do this thing. So guys, I'm gonna explain what's happening. Let me go to. All right, this works. Okay. So guys, so the thing with identity matrix is it is always a square matrix, right? So if you pass 2 over there, it will always produce a 2 comma 2 matrix. So an identity matrix cannot be, something like you can pass 3, then the output will be 2 comma 3, because the diagonals are going to be 1, all ones, right? So it has to be a square matrix, right? So you can just pass one integer in this. So if I go to the code again, we are just passing 2. That means it will create a dimension 2 comma 2 matrix, right? That's it. So here when I'm trying to run the code, see, now I've got the binary file and I'm trying to just call it by dot slash torch because that was the project name. So when I call this thing, it gives me an identity matrix of 2 comma 2 size, and you can see 1 and 1. So it is giving us a diagonal matrix with all ones in the diagonal. So I can change this to maybe 6 and do make again, and that is it. Okay. Yes, Senpai, that's very right. You got the point. Nice. I'm sorry. Sometimes it can happen that I forget what's the syntax, but that's how you don't really need to remember everything. So guys, okay, let me just clear the screen and run this again. So you can see, right, 6 comma 6. So this is a 6 comma 6 identity matrix with all ones over here. Right? So you guys can understand what's happening, right? Yes or no, guys? Streaming is difficult. All right. So we are almost reaching to the end, guys. We're not gonna go to PyTorch C++ like complete details. We're gonna start that from tomorrow. But just I wanted you all to understand what's deep learning, how to set it up and everything. So you can also create a tensor which is random using torch rand function. So again, I'm just gonna try, and I guess this will work. So this is the this should be the syntax of it. Okay, I'm just gonna delete this thing. And let's try to make this thing again. So understand that, okay, if this is going to give me an error now, it will have a trace back, so I can just go and look at the function signature and understand what's going wrong. So right now it compiled fine for me. What happened? Oh, okay, I didn't print the right variable. So I was printing tensor here, which I created. I should print x random because I wanted the random matrix to get printed. Okay, so it's going to be of dimension 1 comma 4. That means what, 1 row and 4 columns. I hope so. Yes, I hope so. Okay, so what I'm gonna do is .krshimani torch, and I'm gonna run this. So if you guys see, we have one row and 4 columns, and we have random numbers from 0 to 1. Okay, so this is how it's gonna be: 0.6154, 0.5715, 0.8044, 0.0416. So this is how it's gonna help us. Right, sometimes we just want to use random numbers. We don't have something in mind. We don't want people to use their birth dates as their numbers, so we can just use random. Okay, rand variable. Okay, that's it. So not R&D variable, no, sorry, R&D function. Sorry. Uh, English is difficult. All right, guys. So this is something we have done today. We have tried to run, like we ran a few PyTorch codes, right? It's in C++, right? So you what you can do is you can exactly replicate these results in Python. You can do torch.i of 6, that will be in Python. You can do torch.rend 1 comma 4, that will be in Python. So that is it. So everything is super easy and matching from Python to C++. So that's why what I'm gonna do is whatever I will write in Python or C++, I'm gonna write in another language as well. So at every stream you're gonna learn both of them. So don't feel like you will not learn it in Python and all. We'll be doing both Python and C++, but C++ is the priority. Okay. All right, guys. It's time to get into chatting mode now. I'm gonna shift myself here. No, let's shift here. And it's where did this go? All right. Uh, Senpai, introduction to debugging codes 101. It's nice. uh, Guys, okay, as now we have 14 watching. Everyone who is in the chat who is watching, please say hi. It's time for a GitHub raid, guys. Are you ready? Are you ready for a GitHub raid, guys? It's time for a GitHub raid, and for those who do not know what is a GitHub raid, so it's like we want to show our love and respect to the developers who are there, who are working hard but are not getting enough, attention. So what we're gonna do is we're gonna go to the code on GitHub and we're gonna star that repo. So this giving stars on the repos means a lot. Trust me, it makes me the happiest. It makes me the happiest whenever I see some people who get the attention they deserve. That's really happy time. Okay. Um, oh, that's Senpai. Yeah, Andrew NG's course. Yeah, it's kind of so Andrew Neg is he goes too much theoretical. I prefer the fast A method, which is like go from the implementation to theory. So, anyways, we're gonna go to the theory. That's for sure. I promise. Okay, but then we're gonna start with the coding first because it's interesting. Can you rate Green Robot Robotil? He's paralyzed. Why is he streaming, bro? He should take care of himself, okay? I of course have full respect for him, but just uh, please don't do promotions here. See that's the, see work hard. You will find the way to progress in life, okay? And God bless him, okay? God bless him. He doesn't need a rate right now. I don't think he needs a rate. He needs treatment and he needs to be fine very soon, okay? He should not be on YouTube. And Senpai, thanks a lot for your comment as well. Sorry, I talked about Andrew Neck, but I didn't thank you. So, guys, it's time for a GitHub rate. Okay, we're gonna rate the GitHub person who is doing a lot. So let me share my screen and let's talk about let's make a developer happy, guys. All right, just a minute. Right, okay. Let's go to GitHub and let's search for PyTorch. So earlier we used to use the keyword of OpenCV, but now we're going to use PyTorch. So let's try to find someone who is working really hard for. So how do I do? I always go to recently updated. Okay. Jaideep Murkote, PyTorch focal loss. Okay, it's not ready yet. Coral PyTorch, Coral ordinal regression utilities. Oh, he is he's super nice. He's the author of one of the best books in machine learning. So we definitely cannot rate him, but then he's really nice. So if you understand what he is trying to do is compressed enhanced ground truth. So it's trying to enhance the image But we'll do all of this, okay, when we are doing it in Python. Let's go to C++ and see if someone is trying to do anything in PyTorch C++. So if you see that very less people are trying to do it in C++, okay, but this is nice. So what he has tried to do is he has tried to make it easier for people to use C++ for deep learning, is it? So he's trying to make it easier for people to use C++ for deep learning. So this is nice, guys. I'll tell you what, to download a dataset, to load a dataset in C++ is really tough right now. So he has kind of introduced some utilities in it, okay, and he has done good work. He has done good work in the README so far. He is working hard. He has only 8 stars, so he definitely deserves more. Let's go and should we do this guy? Should we rate this guy, everyone? Do you think he deserves stars because he is working in C++ for PyTorch, which is, a lot of people don't have heart for that. He he has done good work in updating the README and everything. So I really like organized projects. So it's nice. It's nice. Can I just go and look at the code? See, this is nice. The indentation is nice. I like that. Okay, this is nice. And who is this, by the way? I'm an ordinary. Oh, you're not ordinary, bro. You're doing good. All right. Uh, okay. Why is he crying, by the way? I may be slow to respond. Oh, that's fine. That's fine. That's totally fine. Okay, guys. Let's go to this repo. I just spammed the link. Okay. Just go to this repo and start. So make sure you have from 8 to how many? 18? Can we do 10? Can we do 10 stars? Let me just go and start as well. Okay, Navroz bhai did. Mohit, you did. That's nice. Uh, Come on, guys. Go to this repo and star this guy. Okay, let me start this repo. Offset null. Uh, who is this? Offset null. Acha Dakshita. Okay, you are this. You're learning CUDA, huh? That's nice. It's gonna help you a lot. We'll read you one day for sure. Okay, just keep working hard. All right, guys. Keep staring the repo. Keep doing this. Ashish, thank you. We have 13 already, guys. We have done 5 stars already. Let's do 5 more. Let's do 5 more, guys. Can we do 5 more? Whoever is in the chat, please go to the link and star this repo. It's going to help a lot. Let's get him to 18 stars. Uh, oh, Senpai, that's nice. Done 14. Okay, this is Anubhav you. That's nice. Senpai, you might just want to make a new account or forget password. But if possible, please, it's okay if you can't do it now. Just do it after the stream, whenever you find time. Meanwhile, guys, can we do just 4 more? Okay, just 4 more. Let's do 4 more, and then we'll be good to go. Let me quickly ask a few people I know to start this repo separately. Alright, guys, go to this repo and start this quickly. Come on, let's try to get 18 stars. Okay, it's already 11:30. Time pace. Okay, Yatharth, thank you. We have 16 stars. This is Kunal Kishore. Is this you, Sinpai bhai? Sinpai, is this you? I remember the password. That's great. Kunal. Okay, that's nice. Nice name. Kishorda. Should I call you Kishorda from now? Ritik, thanks a lot. Thank you. Okay, we have done 18 stars. Thank you, Bhaiya, for starring. Thank you, Ritik. Thanks a lot, guys. Thank you, Sinpai. Thank you, Yatharth. Thank you. Who was this? Dakshta. Ashish. Thank you. No, he was Anubhav. And this is Dakshta. And this is me. Thank you, Kush. Thank you, Navroz Bhai. Thank you, Mohit. Thank you, everyone, for giving a star to this guy. I thanked everyone. Okay. Thank you, all the people who were before there. All right. Yep. Anubhav got you here. Thanks a lot. Um, and a small message for this guy, guys. Do you want to say something to this guy? Uh, just do whatever you want to say, OP or anything. Just type in the chat. Okay. Meanwhile, Senexin, that's your username. You're doing good job. PyTorch C++ is really new thing. Okay, and I believe that it's something which you are doing is really nice. Trying to get utilities out there for PyTorch C++ thing is really gonna help a lot of researchers and those who are working in the industries. So I definitely love your kind of work, how you have organized. You've also mentioned the prerequisites, which is really nice. The dependencies, directory structure, it might need to be updated. I'm not sure, but then the README is also nice. So good luck to you and thanks a lot for your work. We of course love all the developers out there who are working hard. So earlier you had 8 stars, now you have 18. It's just a small token of love from all of us who are in the chat right now. Okay, and thank you. Thanks a lot. So guys, this was a message for him, for the developer who is working hard. So I think we did a lot of good things tonight. We did talk about we did talk about deep learning, we did talk about AI, we talked about machine learning, we talked about how it all started. So I'm definitely sure that you guys are now motivated to work hard in this field to try and make sure that, you know, if someone can do this from 1950s, you can definitely do it in 2020, right? So make sure that you understand that there's nothing that is impossible. Impossible is just something for those who just want to lose, okay? You guys are made for something which is possible and keep doing possible things. That's fine. You don't need to do impossible, but that doesn't exist, right? All right. So Dakshita, thank you. Thanks a lot. Everyone is so sweet, right? In the chat as well. Thank you. It's all because of you. You guys are passing positive vibes to me. I'm just passing them back so that you guys have a good night as well. It's important for me to stay positive. Sinpai, what do I do? I work for a US company called Care AI. Right now, I was an intern at NVIDIA in the headquarters this year. Because of COVID, I had to come back, but I was there in Santa Clara. I was in the PyTorch development team. So yeah, I'm also a PyTorch contributor. I'm also an OpenCV contributor, and I work with the KRI guys for AI as an AI engineer. That's something I do. What I've done in the past, it's kind of a story, but then uh, how did I get the internship? I didn't get internship. I I was contacted for that internship, so I don't really know how I got the internship. I kept working hard, and just you don't have to fight for getting noticed. You will eventually get noticed if you're doing a good job. So it's thank you guys. Thanks a lot. And nothing like that. I'm not God, and I'm not flexing at all. I'm just motivating you guys to keep working hard. At one point of time, see somebody will come and raid you. Okay, in life he will raid you either on GitHub or in real life. He'll raid you with opportunities. Okay, that's gonna happen one day for sure. So trust the good guys out there. They're gonna trust you for the talent you have. Simpa, I'm 22. I just graduated, so I'm a BTech in computer science engineering from Triple IT. It's a new college, and I just graduated from there. So in July. So yeah, that is about me. I'm 22. I'm a chota sa bacha. No, I'm not chota sa bacha, but then yeah, I'm still young. I got Thank you. Thanks a lot, Senpai bhai. Thanks a lot. So of course, as a part of a Thanksgiving gesture to all of you who have helped me a lot in this streaming, I just want you guys to do exclamation family, and you will know that who have helped me a lot. So Mohit, who is always doing TK by TK karke, so he is also there. Navroz bhai is here. Yatharth is here. Chirag, I think he might be busy, but then yeah. So Vishwesh, my real brother, Lipidi, so Sachin bhai was here. Saurabh, he went to sleep. Pingdrip, she should be playing for now, I think. That was why. Thanks a lot. Thank you. It means a lot, guys. So, also thanks to all the people who have donated me so far. Vinny Bhai, Mohit, Chirag, Adita, everyone out there who have donated. Shubham. So, and this means a lot, guys. So if you want to donate at any point of time, you can of course go to my description and find the donations, details. But I'm just gonna let it be for now. Dakshita, you have a message? Any suggestion for how to get into AI company? Um, Focus on performance, not just on results. Don't just focus on accuracy or trying to replicate results. Try to make sure that your performance is good, because after bachelor's you can't really say that you know all about the networks. But if you all you can do is you can optimize the networks, which is really nice. So that's something that you should always focus on. So because at the end the AI models are going somewhere, right? Um, So that's going to help you a lot. So if you know that all of the models that researchers make, we have to optimize them eventually to make sure that they are running on our mobile. Because this is a sometimes people might use a very basic mobile with not a lot of memory. So your code should work there as well. That is our problem statement. So make sure that you optimize. Work-wise, that is my suggestion. Apart from that, we can have a question and answer session very soon. So we'll talk about it there. Senpai has a message. He's so sorted, bro, in the sense he knows that he loves and he's pursuing that. Me at 24, I don't know what I really want to do in life. See, Senpai, thanks a lot. Thank you. Um, I definitely love my work. I definitely love doing this, and I'm sure everyone will find their passion one day. So I wish you all the luck and thank you for coming as well. I hope this stream helped you. Even 50% it helped you. I'm gonna work hard to make this 100%. Okay. Um, Guys, if you like this stream, please share it with your friends. I know that getting 50 legit likes is really difficult, but right now we got 38 legit likes, I hope. It really means a lot. So please share the stream with your friends. Please make sure that they subscribe. Okay. And I wish all the luck to you guys. Do you think it's time to end the stream? Do you have anything to say, everyone? You can talk to me for 5 more minutes and then we can just say bye bye. No, guys, it's not like that. Come on, you be happy, guys. Come on, you will find the passion. You just stay smiling. Keep smiling, guys. Come on, keep smiling. Is it? Yeah, it's not up to date, right? Uh, hey Nitin, what's up? Yeah, you're still awake, right? So Nitin, I changed the timing for you only. Earlier it was 10, now it's 9. So you can come, before sleeping. And thanks a lot. Thank you. So Nitin is my junior, guys. He's one of the really sweet guys out there. Thank you, Nitin, for joining. Thanks a lot. Ashish, your sub count, yeah, for sure, I'll update that. Mohit, Mohit, कुछ और ढूंढो यार. Come on. Come on, guys. We have 330 subscribers. Thanks a lot to everyone. I'm not doing a lot of promotion, to be honest. Uh, but because I don't really like to play the YouTube game for now. It's as I always say that it's a YouTube game that I have to play one time to get views and likes and subscribers. But I'm really occupied in doing good stuff for the society and which has an impact. I'm gonna let it be, and I'll let the natural ways decide my my faith in YouTube. Okay, so as I said before, I'm gonna stick with Saturdays and Sundays for live streaming because as you can see that I'm really tired already. And uh, on Monday to Friday, I'm gonna release videos, not every day, but maybe once in 2 days or 3 days. I'm gonna release small videos of projects that you can do, so that you can watch it anytime. Live streams are like long streams, right? You can't watch it again. So I'm gonna think about that as well. Thanks a lot. Thank you, Ashish. It means a lot. Mohit, I'm underground for sure, yeah. Yeah, Mohit, okay for sure. Insta. What do you have? Oh wow, that looks like where I stayed, right? Except I was not on the road. I was on the terrace, right? That life. It's so beautiful. All right. He just sent me a photo, guys, where I used to stay as a part of my previous internship. It was a beautiful place. All right. All right, guys. Do you have anything else to say? We can, of course, talk about it, or else we can just say bye bye to everyone. Come on, guys. Any last words in the chat that you have? You have Guni. Yep. So, guys, our good night way. The Senpai, for sure, for sure. So I'm gonna message you personally whenever I'm gonna do that. And if you find time, you can of course join for other streams as well. But yeah, for sure, we're gonna talk about the intuition so that you will remember it forever. So we're not gonna go through the proof always mathematically, but we'll talk about the intuition so that you will tell to your kids that your father knows back propagation ka proof. Ashish, thank you. Thanks a lot. Yatharth, thank you. Navraz bhai, Gunni, God bless you, man. God bless you. Take care, Navraz bhai. We should talk very soon, okay? I've not done anything so far. I'm very silent nowadays. Senpai, for sure, for sure. We're gonna do both ways, okay? We'll complete it, okay? We'll complete it, okay? All right, guys, it's time for me to say bye-bye to every one of you. All of you, if you are in the chat or you're just watching the stream, if you really like my face that much that you can't come in the chat, I'm not that smart, so come in the chat and say hi, okay? Because um, I really want you guys to say hi in the chat once so that I can say good night to you all. And of course, who will come to the stream will get an advantage whenever they ask me questions. So there are a lot of people who are asking for help. I try to help out those who really deserve it. So you guys, of course, deserve it, whoever is watching right now. So I'm gonna help you guys whenever I can. But I am not, open to help for those who can't help me when I need it. I'm just 22. I have my life to live, right? So I can't open an NGO for that. Dakshta, thank you. Thanks a lot. Anubhav, thank you. Thank you. Thank you guys for joining. I'm gonna say good night to you all. Thank you, Ashish. God bless you, man. So we're gonna do a stream tomorrow as well, 9 p.m. guys. Stay tuned. It might be that we might have a Q&A with someone else tomorrow, or we might continue with PyTorch C API. It can be either ways. So stay tuned. God bless you, everyone. Gunni, peace out. Gunni in the chat, guys. Come on. So Gunni is just my way to say good night. So Gunni, guys. Uh, but ठीक है ना सब हो जाएगा guys. Come on, keep working hard, guys. Stay tuned for my YouTube streaming, guys. Okay, please share with your friends. It's gonna help me a lot. Just not financially but emotionally. So thank you, guys. Bye bye. Bye bye bye. Senpai, thanks a lot. Thank you. Daksha, you're stealing the Gunni word. Please go ahead and steal it and spread the positivity around, okay? Use it with your friends, use it with your family. They'll be really happy to hear this. Good night, guys. Take care. Bye bye. Love you all, okay? Exclamation family dal do, guys. Come on, exclamation family in the chat. They are the best. You guys are the best as well, of course, but they have been the best for a while now. Bye bye.